All right, section 5.6, where we get into the least common multiple. And this concept will be used in section 5.7 when we add fractions and subtract fractions with unlike denominators. Um, Least common multiple is also referred to as LCM. All right, and our learning targets are to find the least common multiple of two or more numbers and find the least common denominator of two or more fractions, right? And these two um, are related, essentially the same thing. We're just finding the least common multiple of the denominator, which will help us when we add and subtract fractions. So, our key terms, first off, a multiple is a product of that number and a whole number, right? For example, multiples of 5, right? 5 times 0 is 0, 5 times 1 is 5, 5 times 2 is 10, right? And if we just count by fives, those are multiples of 5. Now, every number has a multiple of 0, right? So if I think of the number 4, 4 times 0 is 0, right? And then we would go 4, 8, 12, 16, 20, 24, and so on. When we talk about the least common multiple, it's the smallest non-zero, right? So we take 0 out of the equation, right? And if I'm looking at um, the least common multiple for number 4 and 5, for 4 and 5, I'm finding when do they have the same value, right? And I can see here 20 would be the least common multiple, right? Because, for example, I could keep going. I could say 28, and then I could say 32, 36, 40. And I see that 40 is also a common multiple, but it is not the least common multiple, right? The first time that they run into each other is here, both of them being 20. All right, so that's what it means to be the least common multiple. Now, the least common denominator is just an extension of that. It's taking the least common multiple of the denominators of two fractions, and that tells us how to make like fractions where they would have a common denominator. So, finding the LCM, the least common multiple of smaller numbers, right? We can do it just like we started there, right? I can start with 8, and then I would have 16, and then I would have 24, right? And I can keep going, but I know that if I were to start doing multiples of 12, 12, 24, dot, 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 right? I could go 12, 24, 36, 48, but I can stop there because I know that they run into each other right there at 24. So 24 is the LCM of 8 and 12, right? And I would start with the smaller one because you'll see in number 2, right? If I start counting by sixes, 6, 12, 18, well, I run into that number. So 18, all right, because I would start counting here with 18. So 18 is the LCM for 6 and 18. Now, when we have three numbers, right, I can say start counting by 7, 14, 21, 28, 35, keep going, 42, 49, 56, 63, 70, 77, 84, right? I'm going to stop there because I see that I've matched that one. And I'm going to start counting by 21. So 21, 42, 63, 84. So 84 is the first time that all three of them run into each other. So 84 would be the least common multiple of that set of three. So that's one way to do it, is just to start counting by whatever number you have here, right? So we started here with 8 and we started counting by eights until we noticed that they would be multiples that are the same. And whatever one we run into first, that's our least common multiple. Now with larger sets, right, that could get kind of tedious, but it's possible, right? You could start counting and say, okay, I have 108, and then I would have 216, and then blah blah blah, and then you'd go by 240, and you'd see that you would have to um, sometimes count to high numbers, right? Or you could do it with a calculator, right? You could say 108 times 1, 108 times 2, 108 times 3, 108 times 4, and list them all out, and then find where the least common multiple comes into play. Or we can use prime factorization, meaning I'm going to start dividing out, right? I know that if I divide this by 2, that would be 2 times 54. And then that would be 2 times 9. Let me go in order. 54 is 6 times 9. 2 is prime, so that stays. This would be 2 times 3. And 9 would be 3 times 3. Right? So I've broken that down into all prime numbers. They can't be factored down any further. And I'm going to do the same thing with 240. And I'm going to say, okay, 240 is 2 times 120. And then that's going to be 2 times 10 times 12, right? And you might have done here 20 times 6, right? That doesn't matter. We just have to get it down to all prime. So 2 keeps going, right? 10 becomes 2 times 5, right? And that's the only way to do that. Here, 12, you could say 6 and 2. You could say 3 and 4. I'll go 3 and 4. Okay, so I have 2 times 2, right? That takes care of those. And then the next one, 4, right? I'm going to move that here, is 2 times 2. And then next in line is the 3. And then I have the 5. Those are all prime numbers, broken down as far as can go. So now I just have to list all of the prime factors. So that are there for the least common multiple. So bear with me. And I'm going to pair them off just so I don't double count them, right? So we have a 2. We have a 2. Okay, and then there's 2 more 2's there. So it'd be 2 times 2. Okay, so that takes care of them. Now, what you could do is say, okay, well, there's 4 of them here. That's more. So this would be 2 to the 4th. Okay. Next up is 3's, right? And I see that there's the most that they have is 3, right? So that would be 3 times 3 times 3, or 3 to the 3rd power, right? So I've counted for those. And then I also have this 5 times 5. So then I would type in my calculator 2 to the 4th times 3 to the 3rd times 5. And it should end up being 2160. 2160 is the LCM for 108 and 240. Okay. Now, bear with me. I know that was new, a little bit confusing. So here's what I want you to do. I want you to pause the video, and I want you to start by breaking down 45 into its prime factorization, and then break down 105 into its prime factorization. And then we'll look at, well, how do we take that and make it a LCM? So pause the video here and just do the prime factorization. All right, so for 45, you should have 3 times 3 times 5, right? And you might have that in different order, but I like to write it with the smallest ones first so we can match them up. All right, so I can see that the factors, we have 3's, we have a 5, and a 7 are all the different ones. So I know that the most here is 3 squared, right? Because I could pair those up, and then I still have that one. So we'd have 3 times 3. And then we have times 5, right, which would be from there. And then I also have times 7. So 3 squared times 5 times 7 equals 315. Okay, 315 is the LCM of 45 and 105, right? And again, that can be a little bit confusing. But remember, you want, if you have 2 3s and that's the most, you need 3 squared. Okay, so you take whatever has the most factors when you write it down, and you have to make sure you get all of the different ones in there, right? Your other option would be to say, okay, there's 45, 90, 135. 180, right? And just count by 45s, and then take 105 and do the same thing. 105, 210, 315, right? And you'd notice if you had kept this going, you end up at 315, right? Because that'd be 180. That would be 225. That would be 270. And then 315. Oh, there we go again. 315 is where you run into this pattern here, right? So the LCM of 315. Now, when variables are involved, okay, let's look at them. And I know we could list the number part, but what I'm going to do is I'm going to break this down in prime factorization. So I know 18 is 2 times 9. And then 9 would be 2 times 3 times 3. We then have x, and then we have y times y. For 10, we have 2 times 5, and then we just have y. So, all the different factors, right? We have 2, okay? And that's the most in either one, so we're going to have the 2. We have 3 squared. Right, so that accounts there. We have the 5. Takes that. We have an x. Run out of colors here. So though that one's taken up. And then we have y. Right, so we can cross out that. That's accounted for, and y. So our LCM for 18xy squared and 10y, if I type in 2 times 3 squared times 5, I should get 90. And then I have 1x and I have y squared. So the most confusing part is we keep using the term least, and we want it to be smaller. We want a least common multiple. And I get that's confusing, because when we go through here, we take whatever has the most, right? Well, there was only 1, 2 from each prime factorization, so that goes here. There was 2 3s, right? That was the most. There was 1 5, that was the most. There was 1x, that was the most. And then there were 2 y's on this side, that was the most. So we keep using this term least common multiple. And then when we find it, we're actually taking the most of whatever the prime factors are. All right. So I want you to take a minute and just see if you can practice that concept on number 2 and number 3. So pause here and see how you do. All right, let's see how you did there. So again, I went the prime factorization route, and I'll do it with just listing the multiples as well, so you can see. But here, 15 was 3 times 5, and then x squared, there was x times x. 10 is 2 times 5. So I looked at the different factors. I see a 2, a 5, and a 3. At most, there was 1 2. At most, there was 1 5. Okay, and I could have picked either one. I mean, there's 1 in each of them, but that's the most in either one. There's at most 1 3, and 2 x's was the most. So those are what I multiply together, right? 2 times 3 times 5 is 30. X times x is x squared, right? Again, I get that that's confusing. That's the least common multiple. Keep using the word least, yet we use x squared, right? Where if you remember when we were factoring, we had to take whatever the smallest was, and that was considered greatest common factor, right? So we keep using the opposite, right? We're saying least common multiple, yet we're taking the greatest of the factors in each term. And then when we're saying greatest common factor, we're taking the least of the variable power when we do that. So I get that that's confusing, but we got to continue to seek that understanding. Number 3, and let me go back. I want to do the multiples, right? So in order to get a multiple of x squared, I need another x in there. So I need 2 of them. And then if I look at the number 10, right? So 10, 20, 30, right? 15, if I start counting 15, 30, that's where they run into each other. There's the LCM. You might have recognized in number 3 that 36 is a multiple of 4, right? So that would be the least common multiple. Or if you did the prime factorization, I did 4 times 9 first, and that's 2 times 2, 3 times 3, and then you have a times b. 4 is 2 times 2, and then you have a b there. So my factors were 2, 3, a, and b. So if I look at where do I have the most, I have either one. I could have, there's 2 there, there's 2 here. So you had 2 2s, you had 2 3s. The most you had in either one was 1a. The most b's you had in either one is 1b. So it'd be 2 times 2 times 3 times 3 times a times b. So if I multiply that out, I get 36ab is the LCM of those 2 terms. All right, least common denominator. It's simply the LCM of just the denominator, right? So what is the LCM of 2 and 8? And the answer is 8, right? And I could say, okay, well, it's 2, 4, 6, 8. Oh, I ran into it. It's right there. Now, how is that used? Because if I were going to add 1/2 plus 3/8, I want to have a common denominator. I need a common denominator before I can add these together. And so it makes it easier if I can find the least common multiple. So that is the least common denominator. I'm working with smaller numbers, meaning if the least common denominator is 8, I can multiply this fraction by 4/4, right? And really that's just multiplying by 1. So I'm just changing the form of it, right? So I can change 1/2 to 4/8, 3/8. And now that they have a common denominator, I can add those 2 fractions together just like we did in section 5.5. All right. So when it says find the least common denominator, you're just finding the LCM of the denominators, right? So see if you can find the least common multiple of 20 and 25. And that would be the least common denominator, because that's what they are, as denominators for those fractions. So do that for number 2 and 3. So pause the video here and find the least common denominator. All right. So if you look here, 25 and 20, again, you could have wrote out the multiples, right? Starting at 20, 40, 60, 80, 100, right? And then realize, okay, 25, I know that goes 25, 50, 75, 100. So there's the first time we overlap. Or if you did the primes, right, it's 5 times 5. Here we have 5 times 4, which is, right, 4 is 2 times 2 times 5. So I had 2 2s was the most here, 2 5s was the most there. That gets me to 100. LCD, right? So I'm looking at just the denominators. So 19's prime, so that'd just be 19 and 1, or just 19. And then we just did 20, right? It was 2 times 2 times 5. So most of the 2's there need that 5. And then I have 19, which is different there. We end up with 380 as the LCM of 19 and 20, which then makes that the least common denominator of these two fractions. All right, comparing fractions, okay, less than, greater than, or equal to, right? And we talked about ways to do this by simply just changing these into decimals, right? And comparing decimals, because we know decimal values and how to look at that. But we're going to look at another way. We're going to look at changing them into common denominators to determine which one's bigger, right? So here I can make these denominators the same if I just multiply this fraction by 4 over 4. So 4 times 1 is 4. 4 times 4 is 16. So this is equivalent to 4/16 versus 3/16. This one is going to be bigger. Here, the least common multiple or least common denominator here would be 45. And to get that, I would have to times that by 5, which means I have to also times the top by 5. So that would be 10 over 45, right? And 10 over 45 and 10 over 45, that means those two are equivalent fractions. Okay, and again, you could type in your calculator 10 divided by 45, that would give you 0.2 repeating. 2 over 9 would also give you 0.2 repeating. Those are equal decimals. So that's another way to do it. Now, with negatives, okay, you have to be careful when they're negative, and I'll show you in just a minute here once we find that out. We looked at 15 and 10, and we knew that 30 was the least common denominator. So I would have to multiply this fraction by 3 on top and bottom. So negative 9 times 3 is negative 27, and that would be 30. Here, 15 times 2, and then negative 14 times 2. So this would be negative 28 over 30. You might say, okay, well, 28's bigger. Boom. It should be this. And that is incorrect. Because remember, when they're negatives, the bigger negative, the further left, which actually means it's smaller, right? There's negative 28 over 30. There's negative 27 over 30, right? Here would be negative 29 over 30. Here would be negative 30 over 30, which is negative 1. So really, this is the bigger value. So you have to be really careful when you're dealing with negatives, all right? Take a minute and see if you can figure out number 4 here. See if you can figure out number 4. So pause the video and give your best answer. All right, looking at number 4, we have least common denominator is 18 between 9 and 6. So I'd have to times the 6 by 3 to get 18. So that'd be times 2 over 3. So 3 times 5 is 15. 3 times 6 is 18. Here to make this 18, I would have to multiply by 2. Okay, so we times that by 2, and we times that by 2 as well, right? Because really we're just multiplying by 1, and we know that if we multiply by 1, it doesn't change the value, right? Meaning that these two are still the same, right? 7 over 9 and 14 over 18. If I type that in my calculator, it gives me the same value. But this way, when they're common denominators, I can compare them to one another. And I know that 15 is bigger than 14, so the 5/6 is going to be bigger than 7/9. All right. I know that was a little bit longer. Good news, your assignment is still short. Page 229. Please work on the following problems, right? Make sure that you are good to go. If you have any questions, please shoot me an email. I'll talk to you soon.